All right, so this lesson, we're kind of prepping ourselves to be ready to deal with fractions. So before we were talking about factors. Today we're talking about prime and composite numbers. So basically, a prime number is a number greater than 1 that has 2 factors only. The number 1 and itself. Meaning the number 2. 2 is a prime number because the only numbers that it has as factors are 1 and 2. 3 is a prime number because its only factors are 1 and 3. Is 4 a prime number? No, because it's 1, 4, and 2. What about 5? 1 and 5. What about 6?
No.
What about 7? Yeah. The only thing I can multiply to get 7 is 1 and 7. What about 8?
No.
Nope. What about 9?
No.
No. So that's the first break in our pattern because before it was all of the odd numbers except for 2 and none of the even. But 9, 1 times 9 and 3 times 3. 10, no. But 11,
Yes.
1 and 11. What about 12?
No.
No, there's a lot in 12. But 13, just 1 and 13. 14, no. 15, no. 16, no. 17, yes. 1 and 17. 18, no. But 19 is 1 and 19. 20,
No.
21,
No.
22,
No.
23.
Yes. Yes.
23 is prime. So, basically, any number that only has 2 factors and itself is a prime number. Except for the number 2. 2 is the exception. There are no even prime numbers. Again, except for 2, because it's such a small number that it only can possibly have 2 factors. So even or not, it still meets the criteria for being a prime number. But other than 2, there are no prime numbers that are even. Now, if they're not prime, they have to be given their own name. Composite. Composite numbers have more than 2 factors. Meaning 4, because 1, 2, and 4 are its factors. 6, because 1, 2, 3, and 6 are its factors. 8, because 1, 2, 4, and 8 are factors. 9, because 1, 3, and 9 are factors. 10, obviously. 1, 2, 5, and 10. Anytime you have more than 1, or more than just the number in itself, it's composite. Now, with composite numbers, these will always be even. Because if something is even, it can always be cut in half, right?
Yeah.
Always. So no matter what, there will always be a third factor in an even number. It could have up to many more than that, but there will always be a third number in an even factor. So, always even, but there are some odd numbers that are too. 15, that's composite. Anything that ends in a 5 is a multiple of 5. If I can skip count by 5s and I will say that number, then it will have more than those two factors. Now, there is a trick, a sneak thing in this room that has been up the entire school year and will never come down. If you look above me, there is a number line. I'm seeing people are pointing to it. Now, you see a bunch of dots over it. All of those dots equal a way to multiply. So if it is a soft yellow, that means it can be multiplied by 7. If it's an orange, it's by 3. Red is by 2. Okay? So when you see those dots, it shows you the colors of what you can multiply to get in there. So if I'm looking at the number 108, I see, now the blue dot, the very first blue dot does not count. That's just the point on the line. But if I look over 108, I see a red, a green, an orange, a blue, a black, and a yellow. Red, green, orange, blue, black, yellow. That is 6 ways. 6 ways that I can make that number. 6 different multiplication facts that I can use to get to 108. Okay? So that tells me that not only is it composite, but it can be formed into 6 different ways. Cool, right? Now, if I look at 107, is there anything there? No, there are no dots there. So if it has nothing over it, it's a prime number. Now, but look at 2 and 3 and 5. Those have dots over it. But notice that the dots over them are their color. Okay? So basically, any number after 12, if it has no dots, it's prime. Any number before 12, if it has 1 dot, then it's prime because it's a multiple of itself. Cool?
Yeah.
All right. So always even, sometimes they're odd too. So let's practice real quick. Number 1, 32. It's just saying, is this prime or composite? Well, first off, my brain goes 2. 2's even. Composite. The minute you see an even number, composite. I don't care if it is 2,348,578, even number, composite.
What if it's just 2?
If it's just 2, you know what 2 is. 2 is prime. The only one. So number 2, 41. All right. Well, first off, I have a big cheat sheet stapled to the wall in this room. All I got to do is look up.
No.
41 is prime. Number 3, 57. Again, cheat sheet. Hello. I'm not taking it down ever.
A green.
So I see 57 has a dot over it, doesn't it? So it is composite. What about number 4? 21. If I don't want to spend time looking for a number, if I immediately know a multiplication fact in my head, it's maybe something that rhymes with Schmevin times free. I immediately know if there's another multiplication fact that's not 21 times 1, it's composite. And if in case you're wondering, Schmevin times free is 7 times 3. Number 5, 95. Again, immediately my brain goes 5. Anything with a 5 and a 0, I can skip count by 5s to get to, meaning it can be divided into groups, meaning it has lots of factors. Composite. And numero 6, 103. Okay? Looking up on my board. Do I see anything?
Nope.
No. So it is prime. Okay?
Yeah.
Now, the only thing that's going to be confusing is when it asks you how many groups can be made. So let's say like for 21, with how many groups?
3.
So I can go, okay, 7 times 1, 1 times 7, 3,
Times 7.
why am I saying 7? 21 times 1, and 1 times 21, and then 3 times 7 is 21, and 7 times 3 is 21. Okay? So when I'm making these arrays, I could have one whole group of 27 or 27 groups of 1. 3 whole groups with 7 in each one, or 7 whole groups with 3 in each one. So if the question is, how many groups can you make with 21? The answer is 4. Okay, because every multiplication fact can be flipped. There's only one multiplication fact that cannot be flipped, and that is a doubles fact. A doubles fact only has 1. Every other fact will have 2, okay? So that's something that you need to remember. It will help you when you're looking at problems, because on the back of your Daily Common Core, it's asking how many groups can be made. Okay? So again, look, what about 32? What do I need to do to get to 32? So 1 times 32, 32 times 1, always.
4 times 8. 4 times 8.
8 times 4, and 4 times 8. If you're unsure, all you gotta do is find 32 on the chart and see how many dots are over it and what.
16.
Okay, so 2 times 16, and 16 times 2. Anything else?
8. There's 2 more. There's 2 more that you can do. No. Wait. No, we got them.
We got them all. So, how many groups can I make? 1, 2, 3, 4, 5, 6. Because I always flip my sentences. Now, if it was for 36, and the question was how many groups can I make? 1 times 36, 36 times 1. And then maybe what's half of 36? So 2 times,
18.
and 18 times 2.
6.
And then 6 times 6. I'm not going to repeat that one because that's a doubles. Is there anything else? Maybe 12?
Oh yeah, 12 times 3.
12 times 3 and 3 times 12.
Wait.
I think that's it. Because I've done 1, I've done 2, I've done 3. 4 won't go in, will it? 5 won't go in, will it? And then there's 6. So I'm good. 7 won't go in. 8 won't go in. 9 won't go in. 9. 9 will go in. So then, if you get stuck like that and you're not sure, just start counting through. 1, 2, 3, 4 won't work. 5 won't work. 6, 7 won't work. 8 won't work. 9. That will help jog your memory. Just start counting to see if you hit all the numbers. So 9 times
4
and 4 times 9. So now how many groups do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9 groups. Because the double does not double. If that makes sense in any way. Okay? So you're always listing. Now this is just listing the multiplication sentences. This is showing the number as a product. This is not necessarily listing the factors. Listing the factors of 36 is just showing 1 and 2 and 3 and 4 and 6, okay? So it's a little bit different. All right. You feeling good about this?
Yes.
I hope so, because literally all you're doing is either writing a P or a C if it's composite or prime. Don't even waste your time writing out the whole words. Okay? Cool.